So question 35, we're taking the boat out for a day on the water. We've got the kids in the back saying, are we there yet? So let's see how you get on. So first things first, a little diagram of what's going on here. And I'm going to initially add the forces to the diagram so that we've got all of the forces on our diagram to see. So here we are, we've got the driving force, D, the resistive forces on the car and the boat, and the tension at either end of the tow bar. And then I've added to the diagram the acceleration and the two masses of each of the car and the boat respectively. So I'm assuming that the car and the boat are both accelerating together at 1.1 meters per second, so I can look at the whole of the system, the boat and the car combined, and write down the equation of motion F equals ma, where F is the resultant force. So when we add all of the forces together, we've got D minus 600 minus T plus T minus 900, that's the resultant force, equals the combined mass of 1900 times the acceleration of 1.1. So when we pop that all into a calculator, we find that the driving force is 3,590 newtons. So we found the driving force of the car. We now need to find the tension in the tow bar. So what I've done for that is I've chosen to look at just the car on its own. We need to isolate the tension into an equation. So I'm just looking at the car on its own. And when I do that, I get the resultant force, which is D minus 600 minus T equals the mass of the car times the acceleration. So here you see that the tension in the tow bar is 1,670 newtons. But I could alternatively have chosen to look at the forces just on the boat. And if I had done that, the resultant force on the boat is T minus 900. That's the resultant force equals the mass of 700 times the acceleration of 1.1. So I get the same answer whether I use the car or the boat. So there we are. Let's have a look at the question again to make sure we've answered the question. Find the driving force of the car, tick. The tension in the tow bar, tick. Hang on a minute, we've got this extra piece here. How have you modelled the tow bar? Well, the answer is light and inextensible. Light, so that we don't have to worry about the mass of the tow bar itself. It's likely to be fairly small in relation to the other masses we're considering anyway. And inextensible, so that we can assume that the car and the boat are accelerating at exactly the same rate. So hopefully you got the same answers as I did. Hopefully I haven't made any mistakes, I don't know. And if you did, well done.